Let's hand it over to Bob for some SAT predictions. Thank you, Jim. First up, in the math section here, we have interpreting linear equations. College Board seems to be making small adjustments on each new exam, but the questions we're about to go over are types of questions that keep showing up over and over again on the SAT. And make sure to pause the video and try each of these questions on your own first. So before we get into it, let's talk about what every part of y equals mx plus b represents in the context of a word problem. So y is going to be our total. X is going to be the thing that affects the total, which is usually time or a number of items being purchased or something like that. M is obviously the slope, but we want to look for a constant rate of change. Think like miles per hour. And then B is our starting point. So let's take a look at this question. And a nice shortcut is go ahead and just skip to the main question. That is usually the last sentence. Which of the following is the best interpretation of the number 2? All we have to do is figure out 2 is which of these? Is it Y, X, M, or B? So in this case, it's going to be taking the place of M, right? So we're going to look for a constant rate of change in our answers. A says the number of years it took. So a number of years is not a constant rate of change. So A is out. B says the average number of feet that the tree grew per year. So that is a constant rate of change. Probably our answer. The height in feet, height is going to be a specific number. Again, not a rate. The average number of years it takes similar trees to grow? No. So the only rate of change is B. So without even really reading the question, we know our answer is B. Now, if we move on over to the English section here, you're going to notice some rhetorical synthesis questions. And without a doubt, you're going to encounter these on the SAT. They always come at the end of the English sections. Just a friendly reminder, make sure to pause the video and try and do this on your own first, but let's talk about solving these. Rhetorical synthesis questions are incredibly easy. First thing we do is we completely ignore the notes. They're going to waste our time and distract us. All we need to worry about is what is the goal? Because every one of these questions is going to be asking about accomplishing some sort of a goal. So here it says, the student wants to use a quotation to emphasize a potential problem with the Wood Wide Web theory. So emphasize a potential problem. I'm just going to try to focus on that right now, and I'm going to start going through and eliminating wrong answers. Describing trees as super cooperators. Simard first suggested that trees can exchange resources with another. All right, so there's no potential problem there, so A is out. In the decay of the Wood Wide Web, Carson and colleagues note that common mycorrhizal networks have captured. So again, it's just sort of stating a fact, doesn't emphasize a problem. After evaluating dozens of CMN studies, Carson and colleagues expressed concern that recent claims about common mycorrhizal networks are disconnected from evidence. That seems to be a problem, so I'm keeping C. D, despite the concerns expressed in the 2022 study, The Decay of the Wood Wide Web, the Wood Wide Web theory remains popular. Okay, so this is a little bit tough because they both mention concern, right? So if we're emphasizing a potential problem, we want to focus on one problem. D mentions that there were concerns, but the main idea is that the theory is still popular, whereas C, our correct answer, gives a specific concern about claims being disconnected from the evidence. So without looking at the notes, our answer is C. Next up, we have constant questions with infinite solutions and no solutions. This one says it has infinite solutions. Basically, this means that these two expressions are going to be exactly the same. One of the tricks with these is that you really don't need to worry about your leftover number that is not attached to x. So this 16 and this 8, if it's infinite solutions, they are going to end up being equal. But if it's no solutions, then these numbers would never end up matching up. Regardless, you can focus on what's attached to x and just make sure that those match up. So what do we multiply by to get 2x? We multiply by 2. So A is going to have to be 2. Let me show you one that has no solution so you can see what I mean. Same thing, we're just going to focus on getting something that's attached to x. So for this one, we're going to have to take an additional step and actually FOIL this out. B times x is going to be bx. I'm just going to write it over here. Negative 2 times x is going to be negative 2x. So we have bx minus 2x. And I was telling you that we don't want to worry so much about the number that is not attached to x. So in this case, it would be 8. What we do need to do is we need to move the 2x over so that the bx is by itself. So we're going to add 2x to both sides. Go ahead and draw this down here. And then we get bx equals 2x plus 8. And again, we do not need to worry about the 8 here. So we're actually just going to get rid of it. Basically, bx equals 2x. So it looks like, again, our constant equals 2 because they need to match up. Go ahead and try this question on your own first. I'm not even going to say what type of question it is yet because it'll give it away. So pause the video. All right. Now this is going to be a question testing your knowledge of colons. I mean, punctuation in general, but the correct answer here is going to end up being D. Let me explain why. So colons, a couple things we need to think about. The number one thing we want to remember is they must come after an independent clause. So an independent clause is something that can stand on its own. You could think of it as, more or less a full sentence. That's the number one thing we want to think about. Once we've checked for that, there are a couple of things that they tend to do. So colons introduce lists. That's probably the most common. Colons resolve cliffhangers. Colons give an example. And these are the 3 most common things that you're going to see colons doing on the SAT. I'm not saying this is all that colons do, and even that first rule isn't necessarily true outside of the SAT, but within the SAT, this is what you need to remember. Let me give you an example of each, and then we'll go ahead and use this to solve this question. So a list might be something like, I love 3 things: dogs, cats, and pizza. Resolving a cliffhanger. So a cliffhanger is when you are left wondering what happens next. So an example of this could be something like, at that moment, something terrible happened, and then you want to resolve it. My mom ate the last slice of pizza. And then an example, I'll give you an example of an example. My cat is very cool. She wears sunglasses all the time. So as you can see, we've got a statement that my cat is very cool, and then we have an example of how my cat is very cool. So these are the 3 things that you want to look out for. And notice that we don't necessarily need a full sentence after the colon. So our first example, we do not have a full sentence. But you could also have a full sentence after the colon. The only thing that must be true, again, is that you have to have that full sentence or that independent clause before the colon. All right, now let's take a closer look at this question. So if we look at our blank space, we've got this really long sentence starting from in a 2016 study. And I like to simplify things as much as possible. So if we have an introductory phrase, we can get rid of that. So we've got Eastern Washington University psychologist Amani. I'm not going to try to pronounce that. We could simplify that too. We could just basically say like, this psychologist found that, and then we've got a comma among the study participants, and then we've got another comma. So whenever you have a comma sandwich like this that sort of interrupts the sentence, you can get rid of all that stuff as well. So our sentence becomes, this psychologist found that there was one personality trait that they scored particularly high on. That's a full sentence, right? And then what comes after the colon? Openness to experience. So we don't have a list, so it's not that use of colons. I would say this is a cliffhanger. It tells us there was one trait that they scored particularly high on. So the cliffhanger is, well, what's that one trait? We want to know, right? So that's why D is going to work. And in case you're curious as to why the others would not work, A, we could end with high, but then all of a sudden we have on openness to experience as its own sentence. That's not a full sentence. B, We've got a semicolon, which could separate two independent clauses, but openness to experience is not an independent clause. So B is not going to work. And then C, we have no punctuation, which is just a straight up run-on sentence. We definitely do need to separate those two independent clauses. So C is out as well. Next up, we've got probability questions. And for these guys, we really want to just think about what does probability look like on the SAT. We're always going to have some sort of desired outcome divided by the possible outcomes. And let me give you an example here. Let's say I wanted to know if I flip a coin, what is the probability that I will land on heads? So there's only one head. My desired head is 1, but what's possible? There are 2 possible outcomes. There's heads and tails. So possible would be 2. That's a very simple and straightforward example. But if we can identify our possible and our desired, it really becomes quite easy. So if you haven't already, pause the video and try this question using that principle. But I'm going to go ahead and get started. So again, I like to go straight to the main question and kind of work my way and then decide what parts of the text I want to look at after that. It's asking me the value of X. So right away, I'm going to look and I'm going to see that X is, here in this chart. So I know that that's what I'm aiming for. Now, picking through the rest of the question, I can see that the first sentence is really just giving me facts that I don't need to know. I don't care what these things actually mean. I just want to focus on the numbers. And then the second sentence is describing the chart that I can see. So I also am going to ignore that. And what I really want to focus on is if one of these people who is rhesus negative. So that if statement, if one of these people who is, these phrases are indicating that this is my possible, because we're not talking about the entire chart. We're talking about one of the people who is rhesus negative. So where's my rhesus negative? Well, we see that this says rhesus right here. And then there's our negative. So basically my possible is going to be here. So before I do anything else, I'm going to go ahead and write my possible. We've got 7 plus 2 plus 1 plus X, or 10 plus X. We know that's our denominator. Okay, now let's figure out what our desired is. The probability that the person has blood type B. So we're going to pause there as well. We look at blood type B, and again, we're only looking at this part that I circled. Blood type B is 2. So we know that our numerator, our desired, is 2. Cool. And then finally it says is. A little trick for you. The word is means equals. That is how you translate that into math. Let me move this over. Is 1 out of 9. So this equals 1 out of 9. All right, now we've just got simple algebra. We can go ahead and cross multiply, which means we're going to multiply our diagonals. So diagonal from 2, we have 9. So 2 times 9 is 18. And this will be equal to our other diagonal, which is 1 times 10 plus x, which is still just 10 plus x. From here, we subtract the 10, and then 8 equals x, which means our answer is 8. Let me give you a chance to try this one as well before I name the type of question. So pause the video, and I'm going to call this our odd verb out questions. The reason I call it that is because we can get through these very quickly by choosing the odd verb out. And let me show you what I mean. All we have to do is use he, she, or it. I'm going to go ahead and use she. And in addition to that, I'm going to use they. So either he, she, or it, and then they. And I'm going to use these words in front of my answers and decide which one is the odd verb out. So for A, we would say she hasn't been. For B, we would say she wasn't. For C, we would say she isn't. And sure enough, there's an odd verb out. We would say they aren't. So our answer is D, they aren't. It really is that simple. As long as you are dealing with a subject-verb agreement question and not a verb tense question. And you'll be able to tell because if it's a tense question, this trick just won't work. You won't only have one odd verb out. You'll have a couple of answers that work for each. And just to kind of show you in context how this ends up working, our subject is the artistic talents. So we have a plural subject, talents, and then we would say the artistic talents aren't. Our next question type is scatter plots / lines of best fit. And there are two things that I want you to be careful of when you encounter these types of questions. Number one, be careful and make sure that your y-intercept is actually your y-intercept, because sometimes that is not going to be the case. And the way to check for this is just to make sure that you actually do have 0, 0 in the corner here. In this case, we do have 0, 0. But for example, if this 0 were, I don't know, 20 or 30 or anything other than 0, then what looks like our y-intercept would not actually be our y-intercept. The other thing I want you to check for is to make sure that the x-axis and the y-axis are growing at the same rate. And sure enough, they are not. The x-axis is growing by 10 each slash, and the y-axis is growing by 1 each slash. Why is this important? Because if you try to just eyeball what's going on with the slope, for example, you're going to be in big trouble. All right, now that we've looked at that, let's see what's going on here. Basically, it gives us the equation, and then it asks us what's being predicted. So going back to those definitions we talked about at the beginning of the video, our constant rate of change should be 0.096, because that's where m goes, right? Remember, we're thinking y equals mx plus b. So that's our constant rate of change. And then our starting point is going to be negative 0.488, more or less, right? So now what we can do is just go through and eliminate any answers that are telling lies. A says each year between 1940 and 1910, so every year. Now keep in mind, this is going by 10 years, right? Each year, the average increase was $0.096. So let's kind of look at this. If we go roughly from here to here, that's about $1, right? And that's over the span of 10 years. So about $1 would be 0.96. If that happens in 10 years, then 1 year we would just move the decimal over one place, right? And we would get 0.096. So not only is that the constant rate of change that we were looking for, it also makes sense when we look at it visually. So we don't need to go any further. A is our answer. Next up, we've got transition questions. Without a doubt, transition questions aren't going anywhere. You're certainly going to come across one of these questions on the SAT. And these questions are all about context. You're going to want to look specifically at the sentence before the blank space. Then you're going to look for keywords or phrases that indicate the kind of transition you're looking for. Let me show you what I mean. So we're going to go and read through this. When one looks at the dark, craggy vistas in Hitoshi Fugo's evocative photo series, one's mind might wander off to cratered surfaces of faraway planets. Then we have our blank space. It's the series title, Flying Frying Pan, that brings one back to Earth. Okay, so I'm already seeing sort of a connection here. The first sentence talks about our minds wandering off to faraway planets. The title brings us back to Earth. And hear what I just said. I said but. So I'm looking for a but. I didn't mean it like that. I'm looking for a transition word similar to but. All right? Sorry, that's not a very pretty but it'll work. Okay, let's go through, and what we'll do is we'll eliminate if we can't use one of these words in a but fashion. Consequently is a cause and effect transition. I ate 6 slices of pizza. Consequently, I was very full. So that's not going to work. Alternatively is giving an alternative, another option. So something like, we could go and have pizza tonight.
Alternatively, we could get Chinese food. So B's not going to work. So ultimately, doesn't necessarily work the same way as but when we use ultimately, oftentimes it is combined with but because it is a conclusion or, what happens after all is said and done. So we could say something like, we thought about having pizza, we thought about having Chinese food, but ultimately we decided just to eat top ramen for dinner, or ultimately we decided to just eat top ramen for dinner. So here they're saying your mind might wander off into the cratered surfaces of faraway planets. So this thing is going to happen. At some point, though, you're going to come back to Earth. Ultimately, the title is going to bring you back to Earth. So my but prediction was not perfect, but it did help me find the correct answer, which is ultimately. Now, I'm feeling super confident about this, so I'm just going to circle it. If you were not, you would definitely want to go ahead and eliminate additionally as well. All right, our last type of math question I'm predicting will be on your SAT is a lines and angles based question. And for these questions, there are several concepts that you're going to want to know to sort of play ring around the rosy and get to your answer. For this one in particular, the first geometry rule I'm going to use is the straight line rule, which is basically a straight line is 180 degrees. And we always want to start with something we know to figure out something we don't know. I see that S as a straight line. So if on one side of this straight line, we have this angle that's 106 degrees, and we know that the full straight line, that angle is 180 degrees, all we have to do is take 180 and subtract 106 to get the missing angle. So that would be 74. So we know that this little angle right here is 74. Now we can use the same 180 rule, but the 180 rule of triangles. Triangles also have 180 degrees. So now we can go 180 minus 74 for this angle, minus 23 for this angle, and we get 83. So we know this angle down here is 83. And then one more time, we've got another straight line here. So 180 minus 83 is going to be 97, which is X, our answer. All right, our last type of question that you are certainly going to be encountering on your SAT are these underlined function type questions. They're pretty easy to spot because a portion of your paragraph is going to be underlined and you're really trying to figure out what the function of that underlined bit is. And when it asks about the function, it's basically asking, what does this part of the paragraph do? And for these types of questions, I do recommend reading the whole thing for context, at least until you feel like you have a good idea of your own prediction. And that leads to my second recommendation, which is to have some sort of a prediction. What do you think the underlined sentence is doing? Come up with that first, and then compare the answers to your prediction rather than relying on the answers to understand the function. All right, let's go ahead and read. Archaeological excavation of Market Street, Chinatown, a 19th century Chinese American community in San Jose, California, provided the first evidence that Asian food products were imported to the United States in the 1800s. Bones from a freshwater fish species native to South Asia. Okay, then we have a word I can't say, Hong Kong-based import-export firms likely coordinated the fish's transport from Chinese-operated fisheries in Vietnam and Malaysia to North American markets. At this point, I feel like I have sort of a prediction because basically this is a hypothesis or a guess about where the fish came from. And then let's just finish up here for context. This route reveals the often overlooked multinational dimensions of the trade networks linking Chinese diaspora communities. Okay, so we have the hypothesis, the guess where the fish came from, and then this last sentence is sort of saying like why that's important, I guess. Okay, so let's go through. A says it explains why efforts to determine the country of origin remain inconclusive. So that's not my prediction. It doesn't say anything about it being inconclusive. It provides information that helps support a claim about a discovery's significance. Okay, so a guess about where the fish came from helps support a claim about a discovery's significance that's presented in the following sentence. Okay, so I did say that that last sentence is sort of talking about why it's significant. So that actually works. It's not a perfect match with what I said, but you know, with the last sentence context, it definitely works. So we'll keep B. It traces the steps that were taken to locate and recover the object. No, it does not. It outlines a hypothesis. Okay, I'm excited because I like hypothesis. That additional evidence discussed in the following sentence casts doubt on. Ooh, okay. So this is tough. This answer is definitely trying to tempt me because it has hypothesis, and I know that it is a hypothesis, but we know that the following sentence actually explains why it is significant rather than casting doubt on it. So D is out. Our answer has to be B.
That's all for this round of SAT predictions. Back to you, Jim. Wow, Bob, great stuff. And to you students out there, make sure to like this video if it brought you some value, and good luck on your exam.